Hi, welcome to educator.com and our series on Java. Today we're going to talk about loops. All right, first of all, loops are ways to repeat blocks of code. In older programming languages, they used to use a lot of go-to statements, and that got very tedious and it got confusing. So in modern programming languages, we have loops to repeat large blocks of code, or sometimes they're small blocks of code, but you want these things to be done many, many times. Sometimes it's only a few times, sometimes it's hundreds or even millions of times. And that would get really monotonous and difficult if you had to retype and include that code a million times because your text file would, be enormous. So there are types of loops, however, and we're going to get into what these types are, what they do, and how to distinguish and recognize them. All right, first of all, the for loop. A for loop uses the keyword for in Java, and it'll execute that block of code a specific number of times. So think about it in natural language or in pseudocode as if we're saying, repeat this loop for 10 times or for 20 times. Contrast this now with the while loop, and the while loop will execute the block of code only while a certain predefined condition is true. In other words, we're saying, do this loop of code while our variable is greater than 100, or while it's less than 100, or while x equals 5, or anything like that. So we're saying, do it while something is true. Then we've also got a do while loop. Now, the difference between a while loop and a do while loop is that the do while loop will do that block of code at least once, no matter what the counter condition is or no matter what the variable condition is. So the while loop, if it's set up in a certain way where it gets triggered to end immediately, the original loop of code does not get executed. Sometimes you want that to happen, sometimes you don't. If you know that you want that loop of code to execute at least once to start out with, then you've got to use a do while loop. So you're saying do it once and then evaluate whether the condition is true, whether you need to run it again or to break the loop and get out of it. All right, while you're running loops, you are going to need to get used to what we call increment and decrement operators. And these are used specifically with counters. And a counter is a sort of a side variable. And just like you'd be counting on your hands while you're counting something, you count your fingers. And while that loop is running, the counter is usually increased by 1. But increment and decrement operators can be done to increase counters, to decrease counters, and they don't even have to be used with counters. They could be used with anything. They could be used with any variable. But in conjunction with loops, they are definitely used to count the number of times the loop has run. All right, so let's take a look at the 4 basic ways to use these increment and decrement operators. First of all, it's all dependent on where you've got the plus plus or the minus minus. And so if the increment or decrement is before the variable, in other words, if we say plus plus x, then that would increase the variable or increase the counter and then use that number in the following code. The opposite is true with the decrement, where it would decrease it and then run the code. The post increment will run the code first and then increment or decrement the variable. And incidentally, this is where they get the programming language name C++, because C, like counter, and then you want to, usually in loops, you want to run the loop first and then increase the counter by 1. So that's the most common use of a loop, and so that's why they named it C++. Java is based on C++, so a lot of the language and syntax that you may know or may have learned in a C++ class, you're going to see this happening very similarly in Java too. Now let's go through some examples here about how these increment and decrement operators get used. Let's say that we're going to use a pre-increment operator and we set up our first variable to have an initial value of 5, okay? So then when we say that we want to change that variable to the new count, we say that the count gets incremented by 1 and then we add 2. So in all of these examples here, you're going to see that we have two things going on. We're going to increment or decrement the count, and then we're going to add 2. And depending on when those things happen, it's going to lead to different variable values. So in this first example, we've got the value of 5, and then we've got the new count, and then we increase the count by 1 and then add 2. So what happens there is that the count goes up by 1. Now the count is 5 plus 1, in other words 6, and then we add 2 to that. So at the end of it all, the count is 6, and the new count, because we added 2 to it, is 8. All right, let's contrast this with what happens if we decrement that value. Same setup here. We start with 5, and then we say decrease it by 1. So now the variable count is 4. So after this code is run, the variable count would be 4, and then we add 2 to it. 4 plus 2 is 6. So the new count after that little snippet of code is run, the new count would be 6, and the count would be 4. Then let's look at our post increment and decrement. So we start with 5 again. Here we say run the code first, and then do the increment or decrement. All right, so here we start with 5, and then we immediately add 2. So now the new count is 7, and then we increase the count by 1. So the new count, so the original count ends up being 6. All right, and contrast that with the decrement. So we say 5, we start with 5, we immediately add 2 to it. So now the new count is 7 again. But then we say decrease. After that's done, then decrease, because we're using a post decrement. So it's whether it's pre or post, that determines when that count value is changed. So now we're saying post decrement that count value by 1 minus minus. In other words, take the count and then subtract 1 from it. And then we end up with the count being 4. So that's the difference between post increment and pre-increment, or increment and decrement operators, pre-increment and post-decrement. Now, while you've got a counter set up, this counter will either track the number of times the loop has run, and then if you want that loop to break by a user-entered signal, then you're going to use a sentinel. So let's contrast what a counter is with a sentinel. A counter tracks the number of times the loop has run, or its iteration, its repeating values, and typically counters are used with for loops. Now contrast that with a sentinel. A sentinel is a signal that the program needs to break, or the loop needs to break. And typically these are used with while loops. And with sentinels you might have a user entered code like as long as the user doesn't enter -1, the loop will continue to run. Or as long as the user doesn't enter 0 is a common sentinel. Or you might say something like, if you're entering product codes, you might have a product code, all the product codes have regular integer values, and if the product code gets entered as 00, where there is no product 00, that will signal. And oftentimes you'll see a message going out to the user like, enter next code, or 00 to end or to quit. So the user knows, and the user is told what that sentinel is, and then the user knows that if I want to end this loop and get out of this program, or at least go on to the next step, enter 00 or enter -1 or enter ABC or whatever your sentinel is. All right, now let's look at the difference between break and continue statements. While you're running loops, you will often need to either get out of that loop or at least end that particular running of that loop instance and then go back to the beginning. All right, so a break statement, as we've already seen with a switch statement, that will cause immediate exit from that loop, or switch statements. So break statements can be used with loops or switch statements. We're going to see both exemplified today. And that will exit that loop and then go on to whatever is after that. If that's the end of the program, it'll go to the end statements. If that is in the middle of the program, it'll go to whatever command is after the loop. Now, let's compare that to the continue statement. The continue statement will just break out of that loop example, or that loop running, or that loop instance, and it will just skip whatever is remaining in that loop body and then go back to the beginning and proceed with the next iteration of the loop. So it doesn't break out of the loop cycle, it just breaks out of that single loop example and then continues to run the loop. whereas the break statement breaks out of the loop entirely and moves on. All right, now let's look at some specific loop syntax, especially the two most common, the while loop and the for loop. First of all, let's look at the while loop. The while loop syntax is a little more simple than the for loop. The while loop syntax contains three main elements: the keyword, the control variable name, and the loop continuation condition. Now, we've got two examples here. First of all, while is the keyword for a while loop syntax example. So in both of these examples, we've got the keyword while leading it off. Then we want to have the control variable name. In this instance, the variable inside the parentheses here is total. So we're running a total. We're keeping track of a total. And we're saying, while the total is something, keep that loop running. The determination as to whether the loop will continue to run or not is determined by the continuation condition. And here, the continuation condition is less than 10. So we say, while the total is less than 10, keep the loop running. As soon as that total equals 10 or greater, then the loop stops. Now, the same thing is similar here. We're saying the variable name is student, so we might be entering student names or student ID numbers. And we're saying that while that student is not, we've got the Boolean operator or the exclamation point, so we're saying while that student number is not equal to -1, then keep the loop running. So here we're seeing -1 is probably a sentinel. And so we're saying we were entering student values and we're entering student numbers. And while we've got more student data to enter, we want to keep that loop running so we can keep entering data. As soon as that while loop sees that we've entered -1, it stops the loop and we move on to whatever's next. Now let's take a look at for loop syntax. Now with a for loop, we've got a little more complicated setup here. We've got 6 elements to a for loop. All right, first of all, the keyword. The keyword is for, and so we've only got one example of syntax here, unlike the while loop where we had 2. So in this example, we've got the keyword. Then we've got the control variable type. And in most instances, it's going to be int for an integer. The counter is going to be just a simple integer number. Then we name the variable. Oftentimes it's named counter, so it keeps it simple. We say our counter is named counter. The variable is named counter. Sometimes you can name it whatever you want. You could name it student. You can name it product. You can, that's up to the program. So most of the time you're going to name it something that is descriptive. Then we're going to have the initial value of the counter. Oftentimes, we set up the counter to have an initial value of 0 or 1. Those are the most common. So we start with the counter as 0 or 1. Then we've got a semicolon. Then we put in what we want the continuation condition to be. We say, as long as the counter is less than or equal to 5 in this example here, less than or equal to 5. As long as it's less than or equal to 5, we keep that loop running. As soon as it hits 5, it'll stop. And then we have the increment variable. Most common is saying that the counter is ++. That's where you get the C. If you name your counter C, you would say that you want that loop to increment as C++. Same thing is true in Java. You could say C++, or you could say another common one is J++. Sometimes programmers use the counter as J for Java, J++, or you could say counter++ or product++, or whatever you want that counter to be. But the post-increment variable value is the most commonly used. All right, now let's take a look at some of these things we've learned in coding examples. All right, the first program we're going to look at here is a program that is going to calculate commissions. So let's say that we're running a sales staff and we're selling products. We're working for a company, and we want to have salespeople that are selling products to customers. And we want that sales staff to be working on commission, and then we want a program to be able to enter their totals, in other words, the number of products they sold, calculate their commission, and then return you that value. All right, so we've set up our program to activate the scanner so that we're going to have information input into the program. We set up our main class as named commission. We have our public static void main statement to start it off. We initialize the scanner, system in, and then we set up some variables. We say that we want a double integer to be named gross. Start that off as zeros. That's going to be our initial gross sales. Earnings, the integer product, that's the product number or the number of products, and then the number sold. Then we set up a while loop here. Look at our while loop. We say while the product is less than 4. So in other words, we have 4 different products that this company sells. And every time you enter your data for a sales staff, you're going to enter how many of those products they sold that particular week. If they sold 0, you enter 0. Otherwise, you enter the number of products. And you're going to do that 4 times, once for each product. So we know that as soon as the user has entered 4 different products, then the program should end. So we say while the product is less than 4. Then we say the product, as we loop through this statement, the product counter, in other words, is going to increment by 1 each time. All right, so then we send the message to the user. Enter the number sold of a particular product. Then we say, in our if-else statements here, we say the product is either going to be product number 1, 2, 3, or 4. We've got a calculation happening here. We say the gross is going to be added to the number sold times the value or the price of that product. So here we say gross equals add the number sold times the value, and then that is going to equal the new total of the gross. And that is repeated for each product. We say that product number 1 costs a unit cost of $134.99, product number 2, $112, and so on. So we've got all of our products identified, calculated, and totaled, and then we end that while loop. Now we calculate the sales staff's earnings. We say earnings is going to equal their commission rate, and their commission rate here is 7.5%, 0.075, 7.5%. So whatever they sell, they get 7.5% of in commission as salary. Add that to their gross plus 500. So we're going to see that the base value, they're going to get a minimum of 500. Our sales staff is going to be a minimum of 500 per week, and then on top of that, they earn their commission. So that's how we calculate earnings. Once the earnings are calculated, then that gets returned to the user so you can see how much they made. All right, let's see if this program works when we run it in our command prompt. All right, I've already loaded the Java files, and we've compiled the code. And so we're just going to run this, and we're going to say we want to run the program called Java Commission. All right, so the first thing you can see it asks us is we want to enter the number sold of product number 1. All right, let's say that our first sales staff entered 5. They sold 5 product number 1s. All right, product number 2, let's say 4. Product number 3, let's say 3. Product number 4, let's say 6. We hit enter. It tells us the earnings this week for that particular sales staff is $712. All right, so that would obviously be the base 500 plus their commission on top of that. Let's make sure that this is running correctly. What happens if we enter 0 for all of the, let's say a sales staff had a bad week, they didn't sell any products, they should still get their base salary at $500. Let's see if that happens. Let's run this again. We say Java Commission. Product sold of number 1, 0, 2, 0, and so on, 0, 0, 0, 0. So earnings this week is the base 500. So you can see if products are sold, the commission gets calculated. If no products are sold, we still have that base value of 500. Let's clear this screen, and we will move on to our next example. All right, here in this program, we are going to calculate average miles per gallon. All right, so let's say that we're driving a vehicle and we want to know what mileage we're getting as we fill the tank with gas, and mileage is very important. All right, so we've set it up, and we've set up our scanner and our original public class. We call it mileage, and we're going to say that we have several integers as variables: miles for one tankful; gallons, number of gallons, how large is how many gallons can you fit in that tank; total miles, and total gallons. We initialize those to 0 for each individual trip or each individual tankful. We set up some double integers, miles per gallon and totals miles per gallon. So as we drive and then refill the tank and drive and refill the tank, we're going to have miles per gallon for that tank full, and we're going to have total miles per gallon, a running total, as we keep filling that tank. All right, so then we want the user to enter how many miles they've driven and how many gallons down here the tank is, or how many gallons they pumped into the tank. Now we have a sentinel. Look at this. We've got enter miles and then -1 to quit. That signals the user that if you're done entering your data, enter -1 and that'll exit the program. If you have more data to enter, don't enter -1. Keep entering real live data. All right, otherwise proceed with the program. All right, so we say while, we set up a while loop, while miles is not equal to -1, then keep running the program. So we've got our while loop set up with our sentinel. So we prompt the user to enter the miles, enter the gallons, and then we set up a safety net here so that we say if the gallons is not equal to 0, because we don't want to enter 0 because you can't divide by 0. So that's a little safety net there, a little troubleshooting. Then we say miles per gallon for this tank full is whatever it calculates out to be. And our calculation is here. Miles per gallon variable is going to be the double of miles divided by the gallons, as long as gallons isn't equal to 0. Then we say total miles per gallon is going to be our variable total miles divided by total gallons. So that's the larger aggregate running total. And then we're going to say prompt user for the new value of miles if we want to go on to the next one, as long as the user hasn't entered -1 to quit the program. All right, let's take a look at this program in action. All right, we are going to run this program, which we have called mileage. And it prompts us to enter our miles, or -1 to quit. Well, we don't want to enter -1 yet. We haven't entered anything yet. So we're going to say, let's say that we drove 300 miles. Enter gallons. Let's say that we have a 15-gallon gas tank. All right, so it says for this tank full, we've got 20 miles per gallon, and our total miles per gallon is 20 because we've only entered one tank full. All right, now let's see, it's the next day or the next week, and let's say this time we got 325 miles on that tank full. Still a 15-gallon tank. Now it says that for that tank full, we got 21.67, and for the overall total, it's running slightly better, 20.83. All right, let's say we did some, all freeway, long trip driving, and we got 400 miles to that tank full. Still a 15-gallon tank. All right, for that tank full, we got better mileage, 26.67, and that increases our overall aggregate total miles per gallon total to 22.78. All right, let's say that we're done now. We enter -1, hit enter, and it quits. All right, so you can see that as you keep entering data, it will continue to calculate. It'll control that overall aggregate value, and then whenever you want to exit, you enter the sentinel -1, and you're done. All right, let's go on to our next example here. And in this one, we are going to find the smallest of entered numbers. So this program is going to ask the user to enter a series of integers, and then it is going to identify what is the smallest value and then return that value to the user. All right, so we call this public class smallest. We set up our scanners and we initialize our initial integer values. Smallest we say is going to be 0. The number is going to be variable because we want the user to specify how many numbers they are going to enter into this program. Integers is going to be the number of integers. And then we prompt the user to enter the number of integers you would like to evaluate. And we say that that's going to be the number. And then the number variable is going to be the actual number, the value of the data entered by the user. Next, we set up a for loop. So here's an example of a for loop. We say the counter is going to be initialized at 1. As long as that counter is less than or equal to the number of integers the user has specified. So let's say that you want to specify 5 integers to be entered, and you want to figure out which of those 5 is the smallest. we say integers is going to be 5. We want to enter 5. And so the counter is going to allow that loop to keep running as long as we haven't hit 5. And every time the loop is run, the counter gets increased by 1. All right, so then it prompts the user to enter their first integer or their next integer, or as it keeps going. And then we set up an if-else statement. We say if the counter is equal to 1, then obviously that is the first data entry because that's what we've initialized the counter to be. Then we want the smallest number to equal whatever that user has just entered, the number. Then, else if the number is less than the smallest, if we're not on the first iteration of the loop, then if the number is less than the smallest, then we want that to obviously be identified as the smallest number. So then we want to say smallest equals that number. And then we end that loop. It'll continue to run that loop for as many times as we need to enter numbers. And then whatever the smallest number is will get returned to the user in the last output statement saying that the smallest number you entered is whatever that number was. All right, let's try this. All right, let me clear this screen. And we say that we want to run the program smallest. All right, so it prompts us, enter the number of integers you would like to evaluate. Let's say we got 5 numbers. All right, enter integer. Our first integer is 5. Next integer, 4. We'll keep it simple. 3, 2, and 1. All right, so it knows because we've set it up so that once we hit 5 integers, it quits. It returns the value, the smallest number you entered is 1. So here, the loop not only knows how many times to run, then it knows what numbers you've entered and it evaluates and it returns you whatever that smallest number is. Let's try this one more time. Let's say we want to run smallest, and let's do something a little more complicated this time. Let's say we want to evaluate 10 numbers, and we'll enter a bunch of random numbers here. And we'll just keep entering numbers until we get to 10, and as soon as we get to 10, then it looks through all of those numbers we've entered, and it identifies that 2 is the smallest number. All right, so you can evaluate a large number of integers or a small number, but the program will keep running as long as that counter does not equal the number of integers you told it that you want to evaluate. All right, let's clear this screen and go on to our next example. All right, here is a little fun program, and it is going to return us the lyrics to the song 12 Days of Christmas. So this is a little something to get you in the holiday spirit, and even if you don't celebrate Christmas, you'll see a good example of how to use a loop to really simplify a tedious process. Now, if you've ever sung or had to sing the lyrics to 12 Days of Christmas, you know that that's a long song if you sing it all the way through. What would happen if you had to write all those lyrics, and not just write the lyrics once, but you start with, Partridge in a Pear Tree, and then you go on to 2 and 3 and 4, and so every time you sing that song, the song and the verses get longer and longer, and it's a good example of something tedious that if we're good with computers, we can have that loop run through that instantly, and we'll really cut down on our singing time, and we can get on to, Christmas cookies and eggnog or whatever you like. All right, so let's take a look at this. We say public static void to start the program. We set up our class as lyrics. We set up our for loop initially for our switch statement down here that is going to identify which part of the loop we're in, first, or which day of Christmas, first, second, third, all the way through 12. We say for the counter is named day here. We start the day as day 1. As long as the day is less than or equal to 12, continue to run the loop. And then every time the loop runs, increase that day counter by 1. All right, so then we say the first part of the lyric is on the first day of Christmas, on the second day of Christmas. As we continue to run through the loop, we're going to say on the first day of Christmas, on the second day of Christmas, and so on. So we go through these switch case statements, and every time the loop is run, it'll go on to the next one until we get down to 12. All right, and then we continue on with the lyrics. We say, on the first day of Christmas, for example, my true love gave to me. and then we add the remainder of the song in the second switch statement. And here's where we get all the different values. So on day 12, it would be 12 lords are leaping. On day 11, 11 pipers piping, and so on. So we've set it all up to contain the correct lyrics to the song. All right, then when we get out of that switch statement, we say print the whole line, and then once we've done it 12 times, according to our loops, then it's going to end. All right, so this program isn't going to take in any user input. Notice that we didn't use the scanner. It's just a way to print these tedious, long song lyrics. All right, let's take a look. We say that we want to run the program Java lyrics. All right, watch what happens when I hit enter. All right, so it ran the whole program in less than a second. As we scroll up, notice the last part. On the 12th day of Christmas, we've got 12, 11, 10, 9, 8, 7, and so forth, all the way down to a partridge in a pear tree. Now, let's look before that. Before that, we dealt with the 11th day, and it only starts with 11 and then goes down to 1. 10th day starts with 10, and so on. So you can see as this loop ran, let's go towards the top here. On the first day of Christmas, on the first running of the loop, it only did the first one. Second, and it continues to add the instances of the loops and of the lyrics, and the lyrics and the verses get longer and longer until we get all the way down to 12, and where we get the whole song. So, if you are studying and you're getting ready for your holiday break, have a great break. Otherwise, continue on with us here at educator.com, and let's go on to our next example. We've got 4 more examples that are pretty simple here. All right, this next example is a do-while loop. We haven't seen a do-while loop. All right, here we've got a public class set up as do-while setup. Here we say the integer, the counter in other words, is I, and we start off that with 0. And we say set that up so that we want to do this system out, simple system out statement while the counter is less than 3. All right, let's see what this does. Let's clear this screen. And we say we want to run Java do while setup. All right, so it just says 0, 1, 2. All right. That's because we set it up as 0, and we said do it while and print out and show us what the counter is, while the counter is less than or equal to 3. So it started as 0, start 1, and then 2, and then we did not see 3 because the loop quit. All right, let's contrast that with our next example. Here we're saying the counter is j, and we start j with 4, and then we say run that, and then we have a j++ counter increment, and print j while the counter is less than or equal to 3. Now, here's the trick with a do-while loop. We've set the counter up to start at 4. When we get down here, we say run the loop while it is less than 3. Well, we already know that the counter is already set up to start as greater than 3. So is this loop going to run? Are we going to get anything? And the answer should be yes, because we're saying run the loop as a do-while loop. So we want to run that system out statement at least once and then evaluate whether the counter should quit the program or not. So let's see what we get here. All right, so we say Java do while example is the name of the program. And when we run it, notice how it runs once, gives us the 4, and then quits because 4 is greater than 3. So that's a good example, a good simple example of what a do-while loop can do. All right, let's try our last couple examples here. This is an example of a break loop statement. All right, here, similar, we set up our counter, start with 0, and then we increment it, and then we say if I is greater than 3, then break the loop. So it'll continue to run until it hits 3, and then it'll end. All right, so let's see what happens here. We run this program, we call it break example, And notice that it runs 0, 1, 2, 3. Once the counter hits 3, it breaks that loop, gets out of that loop. Otherwise, it would be what we call an indefinite loop, and it would just continue to run forever. All right, let's look at our last example. Here we have a continue statement. Now, remember the difference between a break. A break breaks out of it and then goes on to the next or ends it. A continue just breaks out of that, doesn't really break. It exits out of that loop example or loop iteration and then goes back and continues to run. So here we've got a for statement. We say the loop is going to initialize as 0. We say I is less than 10, and then we want to increment by 1. If I equals 5, here's where we get our continue statement. If I equals 5, we say continue. That means that it's going to skip that. We're not going to get this print line statement for that particular instance, and then it's going to continue to run. So let me show you what happens when we run it. We say Java, well, this is our continue example, and when I run it, notice what happens. Notice the counter being returned. We start with 0, 1, 2, 3, 4, 6. Aha, you see what happened. It skipped that fifth output statement because we told it to continue. Stop it, skip it, break out of that loop, go back to the beginning, and continue to run even though we have not fully completed that fifth iteration. Then it goes on 6, 7, 8, 9. So that's a good example of a continue statement. If you just want to signal the program that if a certain condition is met, don't run that particular loop and then go back and keep running until the counter is satisfied with its continuation condition value. All right, so we've seen some good examples of our for loop, our while loop, and our do while loop, and we've learned about post and pre-increment values. And thank you for watching educator.com.